Welcome to the ET380 lecture video on SWR and reflection coefficient calculations. Okay, let's calculate rho, this symbol here, from the SWR, the standing wave ratio. So what we've done is we've measured the SWR from a meter. And our formula here is rho. These bars here mean absolute value, that even if rho is a minus, it's a positive. So we put it in our formula here, SWR minus 1 over SWR plus 1. And we go through and we come up with 0.5 rho. We reinsert 0.5 into our SWR formula, and we end up with 1.5 divided by 0.5. So we have 3. We have an SWR of 3. Okay, next let's find the ratio of the forward to reflected power, also known as the reflection coefficient. Here's our formula. Power reflected over power forward. If we redo this calculation, we come up with rho squared times power out of the transmitter equals the power reflected. Okay, let's do a problem. So we have 100 watts out of our transmitter and we have an SWR of 3. How many watts will we have reflected back to the transmitter, and how many watts will be present at the input of the antenna? So here's our formula. We put the numbers in, so we got 0.5 squared, which is our rho, times 100 watts equals to 2,500 watts. So, 25 watts is our power reflected. So that tells us that we have 100 watts coming from our transmitter, however 25 watts is reflected, which means a net power output of only 75 watts. Okay, so our problem here is we have a directional power meter and we want to find the SWR of the system. First we measure the forward and reflected power, and we assume the forward power is 100 watts and reverse power equals 25. So we plug the numbers into our formulas and we get 0.5 rho. So we have a reflection coefficient of 0.5. From there we can calculate the SWR by putting it into our formula, and we come up with an SWR of 3. So we could also calculate the SWR from the reflection coefficient and the power loss if we know the impedance of both mediums. An example is a coaxial line and antenna. So let's say we have a coaxial cable is 50 ohm and the antenna is 150 ohm, and we use our formula. So we have SWR equals 150 ohms divided by 50 ohms. We need to put the larger on top. That comes out to an SWR of 3. So if we have a 300 ohm twin lead transmission line and hooked it up to a 75 ohm coaxial cable, we'd have an SWR4, and this is not good at all. Okay, let's do another problem. So assume we have a 100 watt transmitter and an SWR of 6 to 1. So what would happen? So we go through our calculation here and we come up with 0.714 rho, and the power reflected would be, using this formula here, would be 50.97 watts. This means 100 watts out of our transmitter and we're reflecting back 50.97 watts for a total only 49 watts less than that. So this is less than half the output power. So we can take into consideration attenuation of the coax cable, assuming the distance from the transmitter antenna 100 feet, attenuation is 3 dB per 100 feet. The actual power of the antenna is only 25 watts. And this is a very inefficient system.